Welcome to T.O.T Academy. My name is Dennis Willie. Focusing on the topic parabola. So we call this part of parabola. We're going to be dealing with the terms associated with parabola. Talking about the definition of parabola, the vertex, the focus, and the distance between the focus and the vertex. Before we dive in, let's discuss on the definitions of parabola. Parabola is the set of points in a plane that are equidistant from a given fixed point called the focus and a fixed line called the directrix in a plane. We take that. A parabola is a set of points just like this. Particular curve is a parabola. This particular curve here is a parabola. This particular curve here is a parabola. And we should understand that a parabola might open on the x-axis or can be open on the y-axis or can also be open on the negative x. The question here we have here is why should the curve, the parabola curve, be open on the positive x-axis? Looking at the equation here, we have the equation y squared is equal to 4p. Y squared is equal to 4p. So if whenever we have an equation with y squared, we know that our curve will either open on the positive x or on the negative x. But a situation whereby we have y squared is equal to 4p x and our p is negative p. Our p is negative p. That means the parabola will be open. The curve will open on the negative x. But at this very point, the p is positive p. This very point, this very curve we have here, the point, the p is positive p. That is why we have the curve open at the positive x. And now what is the p? The p is not the focal point. The focal point, no, it's not the focal point because most people refer the p as the focal point. No, the focal point is the point at which it forms the parabola with the vertex. So the p himself is the distance between the focal point and the vertex. The p is the distance between the focal point and the vertex. And if the p is positive, it opens at the x-axis. Now look at this again. This, when we have our equation is s squared is equal to 4py, that means it means now that our curve will open at the y-axis. And if we have it a situation at this point here now, it means the p is positive p. The p is positive p. But when we have it as s squared is equals to 4py and our p is negative p, it means that the curve, the parabola curve, will be open at the negative y. Now, what we need to understand again is that at this point where the curve open at the origin, it shows that the vertex is at the origin. The vertex is at 0, 0 at the origin. That is why it forms at the curve. In our part 2, we are going to be looking at when it's the curve, the parabola curve, open rather than the origin. It can open at any point, but rather than the origin. Now, let's look at the vertex. The vertex we say is the origin, the focal, this is our focal point, then this is our directrix. Let's get to understand something that the distance between the focal point and the vertex is also equal the distance from the vertex to the line of the directrix. So we also need to understand that the focal point, the distance between the focal point at any point of the parabola. Now look at this now. Let's look at this. You see the focal point, the distance between this to this point where it meets the curve is also equal to the distance from this particular point to the line of the directrix. Now let's pick an equation to show when when the curve opens at the maybe negative, or when, let's look at this, we have y square is equals to 8x. Y square is equals to 8x. Now we can compare these two equations. It means if y square is equals to 4px and y square is equals to 8x, it can also be that, let's keep it as 4px is equals to 8x. Divide both sides by 4x, making the p the sort of the formula. We have divided by 4x, divided by 4x, x cancel x, 4 cancel 4. We have p is equals to, this x cancel x, p is equals to 2. Now, you see at this point, our p is equals to 2. That means this is exactly what we are going to get. That means the distance from the vertex, which is 0, 0, is to the focal point is 2, which is 1, 2. So our directrix will also be negative 1, negative 2. So this is exactly what we are supposed to get. Now, the same way we have y square is equals to negative 8. Y squared is equals to negative 8. Now, at this point here, we have it as we compare it with our equation, which is y squared is equals to 4px. So we're going to be having 4px is equals to negative 8x. Divide both sides by 4x, 4x. So at this point here, we have p is equals to minus 2, because x cancel x, 8 divided by 4 is, we have minus 2. Now at this point, it means that our distance from the focus to the vertex is negative 2. Our diagram will now look this way. Remember the concept. The focal point is at the negative, so it will open at the negative x, something like this. You see this? Because this is at 0, minus 1, minus 2. So the distance between, then this is our focus. Our focus is this, because from here to here is minus 1, from here to here is minus 2. So we got our p to be minus 2. Then our directrix is also 2 units. 2 units, which is, this is 0, 1 unit, 2 units. So this is our line of directrix. You see this? This is our line, this is our vertex, and this is our directrix. So at this point, our focal point is minus 2, comma 0, because this is the x-axis and the y. And our vertex is 0, comma 0, because it is at the origin, while our directrix is equals to plus 2. Our directrix is equals to plus 2.